1 o'clock. Welcome everybody to our next clinic. I just checked the spreadsheet. There weren't, or the Google Doc. There weren't any questions, but I'm going to pause anyway because many of you have joined, and that's great. Are there any questions at this point? No. Okay, then I'll just jump in. Announcements. There is just one announcement that I'm aware of. HDF 113.2 is out, and I linked here the Git tag, the tag on Git. I think there will be a more formal official announcement, but yeah, the release notes are there, and the highlights include the Onion BFD subfiling is there. But then, Dana, is there something you want to say about 113.2?
No, we should have the newsletter on, I think, later this afternoon. The main highlights are just getting out the Onion BFD and the subfiling BFDs. People can test them. There's an experimental release before 1.14 at the end of the year, so I want to get those to the users as soon as possible.
Okay, good. And then we'll you have your corner. We'll come back to into your corner in a moment. But then on the forum, again, this is a very subjective selection of things that stood out to me. We can quickly go through. There was an interesting exchange about sort of collective VDS creation, and I quoted here from the question that the user asked. The problem that the user had was, okay, he had multiple, presumably MPI ranks or multiple processes, and each process had certain data, and it appeared that the pattern maybe was such that not each process owned some kind of a hyperslab or something like that, but it was sort of more randomly distributed. Fine. And then what he tried first was to combine these selections, let's call it that, in a combination, and he tried to use H5S combined hyperslab, but I checked the documentation for that actually states that that is for point selections and not for hyperslab selections. But then assuming that well, it would work even if those selections weren't disjoint, but let's assume for argument's sake that all these selections are disjoint. Of course, you can do a union, just the set theoretic operation of the union of these hyperslabs. But then, of course, you run into this issue of that the order of your grid points, of your points in that data space, is sort of the canonical order. So you have dimensions of a certain rank, like let's say 3-dimensional or 4-dimensional, and then there is sort of a slowest to a fastest changing dimension, as we call it, and that's the order of the grid points. And hyperslab selections, or the set theoretic aggregates, let's call it that, of these operations, they are also processed in grid point order. And of course, if the data in your buffers is not aligned with that order, or the order is different, then, well, yeah, you have a problem. And yeah, so the user didn't like that. And he was trying to go down the VDS path, where he basically said, well, what I could do is not using hyperslabs, but I could create a separate data set for these bits and pieces, and then basically overlay a virtual data set that would sort of restore things in order. And he tried that successfully with a single process, as he said here, but then he wanted to do this collectively, and that he got some kind of error, and he just wanted to know, well, is it actually possible to create a VDS collectively? And I sort of punted that question off to my colleague Neil, and Neil replied, and he actually gave a very nice and pretty comprehensive response. Well, sort of in line with the parallel HDF5 etiquette, what you would have to do is data set creation, for example, and a VDS creation in particular, would of course require to be a collective operation, meaning that he would have to construct the mappings in an identical fashion across all ranks. And so, yes, as an optimization or as a convenience rather, could it be implemented in a way that different ranks provide different mappings, and then in a round of communication, these mappings would be synchronized among all ranks? Could that be implemented? Yes, of course, it could be implemented, although in the back of my mind, I still have doubts about the ordering, because the underlying data set fundamentally must not depend on an MPI communicator, which would be part of this. So whether you have 50 ranks or 2000 ranks or whatever, that should not have any influence on the definition of that data set. And so there are still some question marks in my mind, but putting that to one side, a requirement would be, so this call doesn't exist at the moment. At the moment, if you collectively construct these mappings, the library will not, under the covers, sort of harmonize and merge these mappings. You would have to ensure that you construct the same mappings across all ranks. So rather than that all-to-all exchange living below that call, you would have to implement that in your own code and then ensure that you construct these mappings in an identical fashion. Assuming you do that, there are still additional limitations that Neil listed in his response. So for example, these printf style mappings are not available in this case. Then if you would like to access, if you have different source files, as you would, as the user suggests, they can be opened only as part of this VDS, this virtual data set. They cannot be then opened in other contexts at the same time. And there are also some constraints regarding writing to this data set. And as Neil points out, from a mode, MPI IO mode perspective, things would happen independently rather than collectively. And so there might be all kinds of performance penalties included in that. And then he also points out, yeah, this is not a mode of operation that is currently well tested and well understood. And yeah, so we'll see. It might be interesting to maybe circle back to understand if there is a more common use case here, because of course, yeah, shoehorning this down into VDS is not exactly elegant, especially I think the user later replied he was thinking about like 5,000 ranks or something like that. So when you get into that range and then cobbling together that virtual data set, I can't see that that's going to be terribly efficient. And so interesting contribution though. Any other questions around that, or no? Okay, then remember last time we talked about Tablite. That was sort of an interesting contribution. Again, Tablite, sort of pun on SQLite, but very interesting, a very interesting package. And the user just posted that, hey, maybe this clinic contributed, albeit mildly, to his spike in downloads. So he had allegedly 2,000 downloads in the past month. And he included, I hyperlinked it here in the notes. He points to a test where I think he uses quaternions or something like that. So a rather exotic user-defined Python data type where he shows that he supports as column type. This Tablite is all about tables, obviously, and these tables, these columns are typed. They are Python types, and he says, yeah, I support pretty much all Python types. And what he does is, I look briefly at the code, is of course that he has a certain assortment of types that he supports natively from an HDF perspective, in the sense that, yeah, so ints, floats, and things like that, they are mapped straight to the HDF data type in the HDF representation that he supports. But let's say for these quaternions, for example, and other Python types, yeah, he really, as you would expect, he just pickles them and sticks the pickled Python object into sort of an opaque data set. But of course, he preserves the metadata and everything. But that's how he does that. But yeah, it was a nice response, or an interesting response. Any other questions about, by the way, I can say we don't have a specific date yet, but Lori, I don't know if that's any farther. We would like to organize a webinar about Tablite with a gentleman who is the maintainer and author of that. But to my understanding, we haven't finalized the date yet, but it's something that's coming.
Right. I think probably October at this point.
Okay. Okay, great. So stay tuned for that. I'm sure it's going to be very, very interesting. Okay, and then there is just got underway a discussion where someone was asking, I mean, this question came up in the past where I think someone was asking, can I allocate chunks in an HDF5 file without writing? So in a way, just, yeah, somehow create space so that I guess the desired outcome is that I can get a hold of an address and a range in the file, so that I can then, outside of the library, either make reference to that or access it in some form. And so in this particular case, the user is asking, let's say I want a specific ordering of these chunks, and he makes reference to the the Z curve or Hilbert curve, or you can these space filling curves, this general class of space filling curves. And so he asks, well, is there a way to allocate, not necessarily write, these unfiltered, because of course compression changes everything, in a specific order? And it'll be interesting, I think, just for testing. If you just wanted to test this, what you could do is, actually, since the sort of the dawn of HDF5, you have the ability, albeit for contiguous data sets from a sort of spatial layout perspective, you can actually create a piece of metadata that, for all practical intents and purposes, feels like a contiguously allocated data set, but the data itself can actually reside in external files that can be just flat binary files or some non-HDF5 files. That's the point. And you can achieve that. I linked here to the documentation, H5P set external, where you can basically specify a list of file names and offsets and ranges in these external files. And it can be one external file, or it can be multiple external files, so that when the HDF5 library reads or writes from such a data set with external layouts, that's basically redirected depending on which data set element you are reading, that's matched against that metadata, and then taken or written to that external file. And so if you want a Hilbert curve or a Z curve or something like that, what you could do is just take one external file and then put your data, your chunks in that order into that external file, and then declare that, albeit contiguously allocated file, at least from the perspective of HDF5, because these this external layout is only supported with contiguous layout, so they are not extendable or anything. But since this is for experimental purposes, I understand. And then if you want to explore performance characteristics and whatnot, I think this is as close as it gets that you can mimic this. But then my question would still be, then what? So what is the use case here? And so I'm sure the user will reply and we'll have an interesting discussion. But and to me, this is always one of the beauties of HDF5 is you can mimic, you can try a lot of stuff before you decide, well, okay, I'm going to change my life. In other words, I'm going to change the HDF5 library, or I'm going to make a more profound thing. First, you have the ability to explore this and test this, and then see, is it really as useful as you thought it might be or would be? And any other questions or comments? So the answer, of course, is no. At the moment, there is no, other than sort of that workaround that he suggested, use direct write to mimic the allocation of the chunk. But then, even then, there is no guarantee, or you would be relying on an implementation detail that your, I mean, first of all, there is no guarantee that these chunks will be allocated in some kind of a budding fashion. I mean, it's very likely that they will be allocated in the order in which you would invoke these direct chunk operations. But in terms of predictability, I think my proposal with H5P set external has some guarantees attached to that, whereas the H5D write chunk would rely on an implementation detail that may change at any point. And then, even then, if you think about free space management and all kinds of things like that, it is a pretty brittle experiment. Whereas with H5P set external, you are exactly prescribing or dictating where stuff is, and you can do that in one file, in one external file, or in multiple external files. So you have some leeway there to explore performance characteristics. But then again, at this point, it's not clear to me what his use case is. Anyway, so any other comments or questions on that? And I got to keep an eye on time here.
Gerd,
no?
he did post he did post back just within 37 minutes. So about your use case question.
Okay, then I will go back, because I'm otherwise I will just start thinking out loud and bore everybody here. Okay, Dana, what's new in the engineering department? And we talked a little bit about 113.2, but everything else exciting?
No, we're just starting to gear up for 113.3, which will release in October. That should have multi-data set in it, and hopefully VFD swimmer. That still requires some work. What else is going on? We're going to be working on, over the next month or so, adding some feature flags to the Volt interface, so that may break the construct. Still not 100% sure if we're going to do that or not, but it would just add one field, so it's not complicated for people to change their code. So that should also update the Volt test suite, and then we should have a better way of matching Volt connectors to software that uses Volt connectors. So that'd be a nice feature, and it'll make the Volt test suite more usable. That instead of just seeing a bunch of stuff fail, you'll only see the tests that you care about pass or fail, and other stuff will just be skipped. So that's coming. That's probably the biggest, besides multi-data set and the VFD swimmer, that'll probably be the biggest change for 113.3. And then what else do we have going on?
How did that? Yeah. I remember there was that pull request to sort of to backport the H5D chunk iter function. Is that wrapped up? Or?
That was, so we put that in develop. So, well, I mean, so develop there was a thing with the offsets, the trunk indices that were not scaled the same way that, let's say, H5D get chunk info was scaled. So we made that, and so the guy who did that work made that sync up right, so that those are processed identically. You have to do this moving around yourself, and then we're going to move that to 110 to 112. And so we haven't merged those PRs. The PRs exist. We just haven't looked at them yet because we've been engaged in release tasks. So
Okay.
So yeah, so that was nice. He did some good work.
Mhm.
And what else is out there? I think there's a lot of other exciting pull requests that are in there right now, or have been merged recently. Mostly just maintenance stuff.
Yeah, yeah. And I don't know, last time, I think yesterday was the day when Scott Breitenfeld gave his tutorial, his sort of longer tutorial on parallel HDF5. I don't know how that went, and yeah, if there will be a recording, because yeah, the audience was restricted in a way, and but I haven't heard anything. Yeah, I mean, I would expect. I mean, Scott is a great presenter, so it probably went well. But yeah, unfortunately I didn't have time to attend. And, okay, good. Are there any other questions? Otherwise, I'm going to jump to our last section.
If you have any ideas for what you would like to see in HDF5 2.0, please chime in on that discussion thread. That's something we'll be deciding upon in the next couple of months. But one of the things that I did do is I came up with a tentative release schedule for 2023 based on just, I mean, right now they're just kind of guesses, right? We don't really know what we're gonna do in when exactly we release, say 114.1 is going to depend on people's experiences with 114. If people have issues or we have to change something, when we'll do it quickly, or people want additional features, then that might come more quickly. I'm planning on something probably about mid-year for 114. And then, as we've indicated on the web, and as we've mentioned elsewhere, 1.8 and 1.12 will be retired at the end of this year. So we'll have final releases of those at the end of early next year. We probably won't do it this year. Probably do it in January and February. We'll get rid of 1.8 and 1.12. We'll just tidy up everything that's in there and do a final release of those. No new features or anything, just kind of any bug fixes and alignment that we do between the different branches. And then I think 110 will probably have a release, probably springish, to bring in the performance changes that we've made in Develop. Develop is actually now, and I hope to have a blog post on a couple of things. One is just the number of the warning reduction work that we've done in library, that the library should almost compile cleanly now. There's a couple of remaining production warnings with GCC, but in Clang and GCC, it should compile largely cleanly. In fact, we even have a W error GitHub action to keep people from throwing bad code in the library. But also we made some small tweaks to get the performance of Develop back down to kind of closer to 1.8 that people have noted over the years. Performance regressions, 110 was probably the worst. That was really bad when it first came out. And we've slowly improved things over the years. And now we're at the point where a couple more tweaks will get us basically to 1.8 performance levels, and possibly even down to 1.812 performance levels, which is kind of a baseline that one of our customers is using, and which is even faster than the head of the 1.8 maintenance branch. So we're making improvements there, and we'll move those to 110.10 in probably in March. So I'm thinking now. So I'll have that updated sometime this week on the web, tentative future dates and kind of what we're going to be doing over the next year after this. At least, I mean, that's the plan that I have now. It may change depending on what we do with HDF5 2.0, whether that releases sooner or later, depends on how much work goes into that. We'll see. So.
Okay, and yeah, thanks. I just saw Lori just posted. I misspoke. It wasn't actually Scott's tutorial. Wasn't yesterday. The deadline for registration was yesterday, and the tutorial will actually happen on August 31st. So yeah. Apologies. I misspoke. And I actually I had it on, yeah, if you want to go back, I had it on last week's notes, the registration. And yes, yeah, the registration deadline is August 15th, and then the event itself is, yeah, okay, sorry. But then thanks for the correction. Yeah. Okay, so we are almost out of time, but just something to throw out, and I think I want to start a thread about that. Instead of tips, tricks, and insights, last time we talked about data type conversion, and there was code. Today, there's just a simple, easy snippet of code. There is this recurring question around concurrency, and how do you deal with concurrency in HDF5? And yes, there's the whole discussion going on about multithreading, and then for people who do MPI, their parallelism means something else, and concurrency in particular. But then there also has been, people have used an approach in the community, in particular, sort of people who work with detectors and so forth. They have perfected that for their use case almost to a science. In the sense they use 0MQ, and I picked an example here. I left the link to a tutorial where they do that. So 0MQ is sort of, if you want to call it, sockets on steroids combined with a message queue type buffering paradigm. And so this is just Python code. I'm not going to go into details here, but think of it as yeah, you have a source like a detector that's sort of spewing data, that's generating images, let's say, and basically writing them to a socket as a publisher. And then you have a subscriber, and here's the subscriber code, and you want these frames to end up in an HDF5 file. What you can do is basically, yeah, sort of create the groups, the infrastructure, the profile that you would like, and then the data set, and then you just receive messages. Of course, you as the creator of this publisher subscriber arrangement, you would have to design some kind of protocol how these images get sort of framed or prefixed or annotated so that the receiver then knows, okay, this is the name or the index of the image, and this is the actual payload, the pixels or the voxels or whatever it is. So that's, we are not talking about that here. This is really just sort of a very narrow glimpse of that. But yeah, you are basically receiving strings and objects in this case, and that's great. And so, which if you think about it and try to generalize it, in a way opens up another way of dealing with concurrency from multithreading or multiprocessing. It actually works in both cases, where you could say, okay, if I have an application and I use the HDF5 library as an application extension, then in a way, as far as multithreading goes, you can almost visually argue the HDF5 library is like a wall. So all the threads that you create at the application level, they will eventually run into this wall, which is sort of impenetrable. It's not permeable, if you wish, to these threads. And so, well, what can you do to really get around this wall? And well, what you could do is you could, in a way, decouple. So you would, in a way, adopt what I would call a client-server approach, where your application would become a client that would be decoupled from the server, call it the HDF5 manager or the HDF5 processor. And then you could, in fact, have multiple clients or multiple threads within a given client, depending on how you define it, that could talk to that HDF5 server or manager through a 0MQ socket or set of 0MQ sockets. And then it is really a matter of defining a suitable protocol that is suitable for more than one application. If you want to think about it by analogy, John Reedy's HSDS, highly scalable data service, that's where you translate, so to speak, in a wall connector like the REST wall, for example, you are translating HDF5 API calls into RESTful calls to his service. So it's not too big of a stretch to say, well, this REST API specifies certain ways to address or to refer to data sets, to groups and whatnot. And then there are like the post, puts, and sort of the primitive HTTP operations that then get cast into, okay, now I got to create a data set, or I got to create a group, or I got to add an attribute or modify the value of an attribute or have a hyperslab selection. So I think it might be interesting to start a discussion on the forum, because I know definitely in the light source and synchrotron community, they have created for their use cases these zero-MQ based protocols to deal with issues like this. And then maybe, and from other communities, people will be chiming in, I hope, we could maybe design like the REST protocol or the REST-based protocol that John has for HSDS, we could create something based on zero-MQ. That's just a natural choice, but not necessarily. If there's a better approach nowadays, then let's think about that. It's really just a vehicle to an end. But let's specify, if you wish, the instruction set of an HDF5 processor that allows us, by, in a way, outsourcing that concurrency problem to the transport layer, be it zero-MQ or be it something else, and then on the client side have a choice where you can what I call the HDF manager or the HDF5 server. It might use the HDF5 library. It might use HSDS. It might use, some of you may remember the webinar that JP Swinsky gave about H5 Coro, where he is going straight to the file format and in a multi-threaded, albeit read-only in his case, fashion and so forth. So by creating this, by decoupling, first of all, the client and server, this is something that would use also between two different systems, because the client and server can run on different hosts. They don't have to run on the same machine. They could, but don't have to. But that way you get around this sort of this brick wall of the HDF5 library, pretty much stopping your threads in their tracks. And so, yeah, my plan is the moment I have a little bit of time, I would like to start a thread on the forum to just develop this idea a little bit, and then maybe create something. And it's going to be something, that is, it's going to give you from a behavior perspective more than the HDF5 library. It's not going to give you necessarily the scalability and the deployment characteristics of HSDS, but it will, I think, take the pressure off. That's at least my hope. This whole concurrency discussion. And I mean, zero-MQ has great performance characteristics and so forth, and might be something interesting for many use cases. Anyway, sorry, we are over time already. Any thoughts on that? But then, please, I'll start a thread around this on the forum and then see what people think. Okay, cool. Well, thanks for coming, and join us next week and enjoy the rest of your day. Yep, bye.